Hey guys, in this video we're going to be covering activity 60.3. Our mastery learning objective is I can solve for the missing side of a triangle by applying the side splitter theorem. So the first thing is, well, what is the side splitter theorem? This has to do with when we have parallel lines. So the way that you know something is parallel is that it typically indicates these little triangles here, or sometimes you just see them as arrows. That means that this line is parallel to this line. Very important there because that gives us some information about the sides of our triangle. If you see that those symbols are there, what that's going to tell you is that this side, so this from Q to R, is proportional to the section of that bigger triangle. So I'm going to kind of color code a little bit more than usual, so this way you can see exactly what sides I'm looking at. So setting up the proportion of whatever length that is going to be over that green segment there, which would be Rx. This is then going to be equivalent to that same small triangle. So again, it's going to be blue side, QS, and that has to be over the same segment of the green, which would be SY. Alright, so notice it's basically like that top half over the bottom is equivalent to that little top half over the bottom. So that's what we're going to be using when it comes to setting up this thing called the side splitter theorem. So looking at our first example here, we see example 1. You basically are going to be setting up a proportion again of the ratios of the sides. So looking at example number 1, I'm going to I see my parallel symbols, right? Those are my parallel symbols. Like I said, sometimes you just see the arrow. That's going to tell me that I can set up my side splitter theorem. So I'm going to take this side length, which is 3, and I'm going to place that over this side length, which is 2. Actually, I'll make it green, so this way we can keep between our two sides. So this is going to be blue. Setting that equal to, I have to use the length of that small triangle. So notice this is my small triangle. I'm going to take that length of X, and that's going to be proportional to the side of that bigger triangle, which is right here, which is 3.2. I'm going to go ahead then and cross multiply just like we were doing. So now that we have proportions, we have a variable, we can simply cross multiply and solve. So cross multiplying here, 2x is going to equal 3.2 times 3 is going to give us 9.6. In order to solve for x, we're going to go ahead and divide by 2. And x is going to equal 4.8. So that is the missing side length of our missing triangle. Right, I have that little triangle there. Looking at example number 2, so sometimes our picture is flipped, but again, we do see that these are our parallel lines. So you have to be careful of the way that you're going to set up your proportions. So remember, we're going to be top half of our triangle, so that would be 6. If we set up our other ratio, that's going to be equivalent to the other side of that small triangle, which is 4. Right, our denominators here, bottom half would be x, and then the bottom half over there would be 3. Again, you can't really flip-flop the order. That one side, that 6 and that x have to be on the same side of the equal sign, just like that 3 and that 4 have to be on the same side of the equal sign. So you can't mix up the sides. Then we cross multiply, so 4 times x is 4x. 6 times 3 is 18. We're going to go ahead and divide by 4 on both sides. And x is going to equal 4.5. Alright, last two examples here using our side splitter theorem. Again, it asks us to solve for x. I see my parallel lines there, so therefore I'm going to take this side, 8, and that's going to be equivalent to my other side of that triangle, which is 12. And our denominators here are going to be the corresponding bottom halves of our triangle. So this is going to be x, and this one is going to be 9. Going ahead and cross multiplying. 12 times x is 12x. 8 times 9 is 72. Solve for x by doing the opposite, so that's getting multiplied. You do the opposite and divide by 12 on both sides. 12 divided by 12 is 1, so I'm left with x. 72 divided by 12 is 6. So that is my missing side. Looking at example number 3. Parallel lines, I'm going to go ahead and set up my proportions then. So top halves and top halves would be 10 at the top and x at the top. Bottom halves would be 5 and 7.5. So bottom section of that parallel line, 7.5. And then we are going to cross multiply. Cross multiplying here, 5 times x is 5x. 10 times 7.5 is 75. Solving for x, we do the opposite operation, so we're going to divide by 5 on both sides. And 75 divided by 5 is 15. Alright, so that is our missing side there. That brings us to the end of this video, so go ahead and work on activity 60.3. Good luck!